In this question, we're asked to solve the quadratic inequality 2x squared is greater than 16x plus 66. So how would we go about trying to solve this? Well, let's write out the equation in a slightly different way, because you may have spotted that 16 and 66 are even numbers. So we can factorize this and extract out a 2 and put the rest in brackets. And the reason why we do this is we always try to simplify the coefficients of any terms in a quadratic. So we could divide both sides by 2 and we would end up with an equation that looks like that. X squared is greater than 8x plus 33. We do want to try to get the general form of a quadratic equation, which is ax squared plus bx plus c equals 0, so that we can try to factorize it and then plot it on a graph. So let's rearrange this so that we get 0 on one side. X squared happens to be a positive there, so I'd probably like to keep it positive. So we're going to subtract 8x and subtract 33 from both sides. And if we do that, we get something which looks a bit like this. X squared minus 8x minus 33 is greater than 0. Now, we ask ourselves if we can factorize this, that would be the ideal solution to find where the parabola cuts the x-axis on our graph. And we can factorize this as x plus 3 in brackets and x minus 11 in the second bracket is greater than 0. You can always double check this by expanding out the brackets to see that you get back to the original quadratic equation. Now, similar to previous examples, what we can do is consider the general equation of the curve y equals x squared minus 8x minus 33, which is what we have here. And that's the general form of a quadratic equation. And then because y is equal to this, we can substitute y here. So we end up getting y is greater than 0. Now this tells us that we're basically looking for positive values of y which are above but not equal to the x-axis. They don't touch the x-axis. There's no equality sign there. So everything that's a positive y value. So if we think about that factorization and the fact that this is going to be a parabola, so we know that the curve is going to look a little like this. And in fact, when x equals 0, 0 squared minus 8 times 0, these basically disappear, and your y value is negative 33. Obviously, this diagram is not to scale, but there is the intersection point there for the parabola. So what we're looking for are when our y values are positive. So if we look at any value beyond 11 on the x-axis, let's say 12, just there, then we notice that we get a positive y value. If we looked at 13, we'd get another positive y value, and so on. Similarly, if we look at x values less than minus 3, then we'll notice, for example, negative 4, then we would still get a positive y value. All the values between negative 3 and 11 will give you negative y values. So we're not interested in that region there. So hence the solution is x is either less than negative 3, but not equal to negative 3, because it would then be touching the x-axis, and x is greater than 11, and that would be our solution for this particular quadratic inequality.